Sometimes it asks for like your zip code.
Sometimes it asks for your PIN number? Yeah.
And I can't distinguish that in my head.
Yep.
So I do it both ways. And I've had to like cancel, just keep on going.
I have in my hand the test.
Can you just give it?
No. I don't know why we have so low of attendance today, but that's another story. Nobody told me. Well, no, this isn't. Well, somebody might have a final today, I guess, in Ivy Tech. Nobody told me they had a final right now in Ivy Tech. All right. Anywho, we had a perfectly reasonable set of questions from MJ at Study Hall yesterday. That is, can we make a review sheet that's more useful than necessarily this list of things that I have up here? I have mine loaded up. I'll bring it up here. And can you bring the review sheet in? Let me ask a question first. What would you want on that review sheet? For example, if you want to make a review sheet that has the 7 steps of a simplex method, no, don't worry about that. That's not on the test. So before I get too far on this, let's talk about that. Yes?
Are you saying that we'd like use the review sheet on the test?
Yes. Okay, I definitely can't let it be open book. But if we made some kind of group review sheet and then I print copies of it for everybody tomorrow morning or whatever, I can live with that, I think. What do you want on it, though? I mean, maybe what you're thinking you want on there isn't on the test anyway. We can simplify everybody's life. Yeah.
No, I want the multiplication for matrices.
Well, matrix multiplication? Okay. Here, let me make a list over here. Okay, yes?
Okay, are Markov chains going to be...
Yes.
Okay, so then I'd like something.
Like an example problem.
Yeah, just like...
Okay, let me think about that. I don't know about an example problem, but we can do something about that, okay?
Like,
Yes.
I want like the formula for that one like given. Like F, like E given F. Is that on
Is that on the test?
the
Are you talking about the one that's like Bayes formula?
That's like,
Or
it's
Bayes
like
theorem?
conditional probability.
Okay, let's write that down. Conditional probability.
Okay, so...
And like, I'm going to put down Bayes theorem as well.
Okay, it might be big.
Are we doing least square line?
No.
Okay.
No, the least square is not on there.
And then
Yes.
echelon and echelon are not needed.
Well, hold on. Hold on. Go ahead.
Formulas, I can't remember what we were talking about last time.
What?
Do formulas for...
Was it expected value?
Yeah, that's one of them.
Hey, are we doing minimization?
Well, it's, yes. That's the graphic way of doing linear programming problems.
No, I was looking at matrix. Like this section.
No, that's all like the fancy schmancy simplex stuff.
Okay, so we're not doing
All that fancy stuff, I think that was chapter 4. Hold on, let me finish writing this. Yeah, that stuff is that setup where there's a set of constraints, and then you're like you have an objective function, you're trying to figure out how to maximize or minimize or whatever. The only one we're doing of that is graphical.
And can you, okay, so are we doing anything about sets?
Yes.
Okay, can we do like the intersection and union symbols, like distinguishing and then a union rule?
Okay.
Oh yeah, you
Okay.
Yeah, and then like,
Some of this I'm not necessarily agreeing. Okay, I'm just writing at the moment.
What's the one where we have like... It's like the probability, or we were talking about last time. I remember what exactly it's called.
I don't remember either.
Conditional probability and the product rule probability, like those two.
Conditional probability. And there was like a product rule. Okay. All right. So far, so good. I mean, I can see some things here that are yes and some things that are no. Yes?
Combinations and permutations. The
Yes.
formulas.
Combinations and permutations. I'm not agreeing. I'm just putting them down.
Binomial probability.
Binomial.
That it's gonna be great years.
Binomial probability / distribution.
And expected value.
And we have expected value up there.
Okay.
And in here, this is like also normal approximation. That was that business of z-scores? Okay.
Standard deviation.
Okay.
Variance, I do wanna.
Okay. So far, so good?
Where to put these right now? And let's see, what else bothers me? And now we're on the back on the Markov chains.
Haley, how are you preparing for this test?
I'm just listening.
You're just listening.
Yeah.
I understand. I like it. When I was a student, I would let things kind of wash over me.
What's gonna be from like the last couple of chapters?
Yeah! She's saying the last couple chapters since the last test, right? Yeah. Well, the last couple of chapters have basically been binomial probability and distribution, normal approximation, and also Markov chains. Okay. All right.
So, what really I want to know is like, what are we going to be able to put on the review sheet and what?
Yes, I know. That's kind of what I'm thinking
So
too.
that
Hold
way
on.
I know what to focus studying
Yep.
on. Because
Okay.
I'm gonna crush.
Here's the deal. As I look at their test, remember we got kind of a, okay, so remember we talked about the fact that there was, this is the Ivy Tech test, but they covered less material than we did for various reasons, so it has like a little bit extra added that is EVSC stuff, okay? And I made it so that the only EVSC thing we added was since the last test. I think it's a perfectly reasonable thing to say. Anything, like for example, we covered more things in each of the units than Ivy Tech did. Okay, but you've already been tested on that. I don't think it's necessary for us to go back. If there's already cumulative questions from each of the 4 units we've done, what's the point of testing those things also again? Does that make sense? So you have an Ivy Tech test that covers the first 3 units of the material. They don't get anywhere into this last unit. Okay? For a variety of reasons, not the least of which is many schools teach this as a 2-semester class. Okay. So, which has to be kind of slow. You know what I'm saying? I mean, don't get me wrong, there'd be something to be said for doing more problems and getting deeper understanding, and we did skip a couple chapters here and there and stuff. On the other hand, holy crap, they skipped those chapters too. It'd be kind of slow. Alright, moving on though. Okay, so the only things that are new from the last part is the Markov chains and binomial stuff, and normal approximation. All right, let's do something else first. I am concerned about one particular question that is on their test that I feel like will be rough. There is a problem on their test that says, use Gauss-Jordan elimination to solve this system of equations. And it's 7 points of a 100-point test. Now you can do that. What do we mean by Gauss-Jordan elimination? It's the augmented matrix one, right? Okay, so if we had something like 3x plus 2y plus z equals 10, x plus y plus z equals 3, and x minus y plus 4z equals 5, we would do this by writing this out in the form of an augmented matrix, where we write out all these coefficients, and then we do stuff to this using row operations until you get it in the form where the left side is an identity matrix and the right side has 3 values in it, and that's x, y, and z. I think it's peculiar that they called that nearly 10% of the final. You know what I'm saying? Is that nearly 10% of our course? I mean, we met 45 times. Was 5 of our lectures, maybe 5 of our lectures were about solving systems of equations, because we learned other methods, right? Like didn't we also do like Gaussian elimination and a few other such things? I can't remember. But there were,
We did simplex.
we did
method
one
a
with the
lot.
inverse matrices.
We did simplex method a lot though, which is basically.
Which is a
Gaussian
similar thing.
elimination.
Yeah, which is a similar thing. I do think it's a little weird. We certainly didn't do 10% of our class about Gauss-Jordan elimination. But we certainly did do, I would say 10% of our class has been solving systems of equations. It's odd that they focused on this one and it's worth that many points. Do you feel like you could solve a problem like this?
Yeah.
Or, barring that, get far enough on it, like how should I put it? You'd at least have set it up and started doing row operations. You know how it is. Sometimes you do row operations, get yourself a little turned around, and then you've made an arithmetic mistake, and then you can never get it to work out, and all that stuff.
I can guarantee I'll get partial credit.
How big is the matrix?
3 by 3. It's at 3
Okay.
equations by 3 unknowns.
Well, then that's not too
Because they're trying to keep you from doing things like substitution, right? Realistically, they could have made a problem like this with 2 equations and 2 unknowns and said do it by Gauss-Jordan elimination, but you'd all faked
that's
it.
the pre-cal test.
Yes.
2 by 2.
Yes.
Okay, I had a feeling
Yeah,
it was the
yeah.
same, but-
So they could have done by 2 by 2, but what would really happen is you'd all do it by the easier methods of like substitution or something like that. By doing it by 3, they pretty much wrote you in. You got to do it by Gauss-Jordan elimination, right?
Unless you do it by row echelon. And
Well, that's true. You could also have done this to get it into that row echelon form. There's ways this can be done. But anyway, all right. When I flipped through this test, that was something that scared me. Okay. Also, what scares me is that is the entirety of how much space they give you. So I'll bring you guys some kind of scratch paper or something like that to have that day, okay? Because I think there are other examples where they didn't give you enough space. Okay. I don't even know what the point of that was, to be honest. Of all that. Because, I mean, clearly I have to grade you on the work you did, and there's nowhere near enough space to have anything there. All right.
Oh, I did have one more question.
Yes.
So on the review sheet, it says like, be able to compute the standard deviation. I'm just confused by, and like what you have
Yes.
to do.
Let me take a look at the actual test so that I'm not telling you something that, again, we kind of have to be efficient about this at this point, right? I don't want you spending a bunch of time on a problem. Expected value, probability. Yes, okay. There is a problem where they give you a list of numbers and they tell you to compute the standard deviation. But here's the deal. They give you the formula for the standard deviation in the problem. So, I will actually even, let's get this back out a second. Let me actually show you that problem. Well, I mean, not exactly that problem, but whatever. But I mean, I'll show you the equation they give you. I see nothing wrong with that. You know that there's going to be an equation there. The equation for standard deviation is S is equal to the big square root of the sum of x minus x bar squared all over n minus 1.
I don't know what that means.
Okay, that's great. Let's fix that. So what they do is they're going to give you a list of numbers, and it's a pretty short list of numbers. They're not giving you a 30 or something like that. Let's just, for the sake of argument, make it 5 numbers. How about 10, 15, actually here's the idea. Let's do it this way. I'm going to make 5 numbers. Let's say they measured your, I don't know, something they measured something 5 times and they got, these are the numbers. I don't know, weights of something or whatever. Okay, just real quick here, can we agree that if these are those observations, x bar equals 20? Right, if you added those numbers up and divided by 5, you get to 20? Okay. Obviously, on the actual test, they are not that simple. I mean, but it is computing average first, okay? There's the next bar in here. All right. So then, this is going to be, okay, we're going to need to take the sum of each number's x minus x bar and square it. Let's make ourselves a little table here. So if this is x, what is x minus x bar? Because then we're going to need, okay, so x minus x bar here is minus 10, minus 5, 0, 5, and 10. I'm kind of making a little spreadsheet almost right here if you want to think about it, maybe a table. All right, so then we're going to need that same number squared. Okay, 10 squared, 5 squared, 0 squared, 5 squared, 10 squared. You might remember that the right word for this is either the anomaly or the deviation. It's the departure from the average. Then we squared them. All right, then we got the summation, so we're adding all these up. 125 times 2 is 250. So S equals the big square root of 250 divided by 4. The n here was 5, because that's how many observations we had. And then n minus 1 is 4, and therefore we have 250 divided by 4, and then it would just be cranky numbers. Okay? It's a small list of numbers, like fewer than 10, let's say. You make yourself a little table like this and you'll have it cranked out in no time. Alright? I don't love the fact that they asked you to do it. Next year, I've got a note on the day we did standard deviation stuff. You might remember on the day we did standard deviation stuff, we just sort of said it's a number, your spreadsheet will give it to you, and then we just used it in things like computing the z-scores and stuff like that, right? Okay, I've got a note now on the lesson plan. Next year we'll do it different, because we know there's a test on the question on the final. Alright, but that's okay. I'm not terribly frightened of it. The fact that you can do this here, of course, already told me you knew how to compute the mean. Okay, remember, the right word for that is actually average. Average is not exactly the same thing as the mean, but your test seems to go loosey-goosey on this. Alright, they're using the word average and mean interchangeably. Hey, if you had that list of numbers there, what would be the median? 20. 20 is the number where there's just as many below it as above it. This one doesn't have a mode. What would be a mode? The one that shows up the most, right? Okay. Alright, so you got those things under control. You don't really need a review sheet for those, right? Alright. I'm going to pull this down here, and I didn't quite make this. I thought I had this far enough over that I wasn't going to overlap here. Alright. So, let's start a blank page, which we will call, oh, you don't have the projector on, which we'll call group cheat sheet for the final. Okay? And this will be a document that I'm going to go ahead and share it right now while the projector's warming up. Let us share this document with all. But I'm only going to make it so that you can view it. I don't want people changing things and then people studied it wrong or something like that, okay, right? If you want something changed to it, you talk to me. So let's see, we want Lisa on there, we want Sierra on there, we want Andrew, Haley, Luke, Malia, and Maddie. And we're going to send it to y'all. Okay. Alright, that way you got it. But you can't change it. I'm always a little skeptical of students changing things. I used to let students, back when I was teaching at Creighton, I'd let them actually make changes to things like review sheets, but what if they change something wrong? And then suddenly people have studied something wrong. If there's something you need added, you talk to me. Okay. On that list up there, matrix multiplication was something that, so this does not obsolete that study guide that I gave you the other day. This is something different. All right. You want to use your study guide to help you study. This is something you can bring in, or I'll print out for you guys to bring to the test, okay? All right, I don't want you to bring your own copy. I want it to be the one I give you, okay? All right, so there was a question for matrix multiplication. Okay. What do you want to say about matrix multiplication, Andrew?
I just can't remember. I know it's like. I just can't remember how to go like the whole thing through.
Sure. Okay. So,
like
if you are multiplying A by B,
we had like, remember how we had like it was like A through F, I think, and then like A, B, C, D, and then all the way through, and then we had like A
Like-
multiplied by.
Hold on a second.
the formula, yes, exactly, okay.
Yeah, where it was
So-
like AB equals like AE plus BG, AF plus BH, CE plus DG, CF plus DH.
Call that product, yeah, okay, hold on, let's be more general about that here. Call that product C. To get row I, column J of matrix C, let's see here. You'll work with row I of matrix A and column J of matrix B. All right, hold on. I know that's not quite as helpful as what you're wanting. I'm coming there. So, to do this, so if you're trying to take, here's A, and here's B, and you're just trying to multiply them out to get a new matrix C, to get this one, like row 1, column 1, you're going to use the values in row 1 of A and column 1 of B. To get, I have a different color here, to get row 1, column 2, you're going to use row 1, column 2. Row 1 of the first one times, row and column 2 of the second one. Okay? So you use the information as to where you are in the product matrix to figure out what you're going to go in. And then what you do is you use this one times this one, plus this one times this one, plus this one times this one, plus this one times this one, however far it takes. Okay? So, let's do a little thing here. Let's just say this was little a, b, c, d, and this was e, f, g, h. I think we're a little bit off the edge of the screen here. Let me move the camera here so that you can see what we're doing. There we go. All right. So here's our matrix. So if we wanted to know what's going to be in row 1, column 1, we're going to be using row 1 here, column 1 here. A times E plus B times G. A times E plus B times G. To get row 1, column 2, this one right here, row 1, column 2, it'll be this one and this one. Row 1, column 2. A times F plus B times H. That's your pattern. How do we want to say that on a review sheet to make you happy? That's the problem. I don't know how to word it either that will make you happy. It's one of those things where when you see it up there, you can see it. This might just take some practice for the test, okay? I have no problem telling you on here just to remind you. So if you're going to have a matrix that's like C here, to get the element row I, column J, you need to use row I of matrix A and column J of matrix B. But how do you want to describe that? Then you multiply and then add, multiply, add, multiply, add. You understand? Okay. Are you good, Andrew?
Yeah, it's easy, it's just hard to remember.
Yes, I agree.
I can do that all on my calculator, so I'm good.
The right word, that's sort of, it's a fake word. But the right word for that process when you're going through here like this is that's a sum product. You add up products. Does that help? Sum product. So you take the product, and you add up those products. That sum product comes from the fact that that's what it's called in Excel. Equals sum product, and you point to like one row and you point to another column, and it multiplies these, element by element, and then adds up all those products. Because there's tons of things out there that are sum products. All right, I don't know if we can add more on there than that, as far as what's on the cheat sheet. All right. I'll keep these things in different orders. What do you want to know about Markov chains that is, okay, that's two different questions actually. Markov chains. What do you want to know and what do you think we want to have on the cheat sheet?
I just have a question.
Yes.
So for like on the actual final, will we have to, you know how whenever we go to another generation, you square like will we have to do that?
No.
Okay.
That is a great question. So what she's saying here is once you have a transition matrix, remember the way you found out like what's going to happen to the second generation, third generation, was you kept raising that transition matrix to higher and higher powers. And that would be fascinating, and it would just take too long. And what if you made a mistake? You know what I'm saying? I mean, all those things are a mess.
Do you need to know about like the equilibrium vector? Because so,
You don't have to compute an equilibrium vector.
right, but are we?
But what is the equilibrium vector?
Yeah, and how? Like, are we gonna have to find it?
No.
Okay. But that would be nice to know what it is.
What do you want to know about equilibrium vectors? That you will not, in the class, on homework sets and stuff like that, you actually compute an equilibrium vector. Hey, what kind of Markov chain led to an equilibrium vector? Regular. If there were no absorbing states, and you could just keep moving, none of the probabilities were zero, or at least some power of it had no probabilities are equal to zero. You could keep moving from one state to another. Eventually, after a large number of generations, you reached a stable situation. There would always be the same number of people in the first class as the second class and the third class. There would always be the same number of people going to Malia's dry cleaner and to Lisa's. Doesn't mean people weren't changing, but it had reached equilibrium. Just as many people were moving from Lisa to Malia as were moving from Malia to Lisa. Just as many people were going from the lower class to the upper class as people were moving from the upper class to the lower class. That has reached an equilibrium vector. Happens for a regular Markov chain. You don't have to compute one. I don't mind telling you that. I don't think that's the end of the world to know that. How was that different from what happened if it was an absorbing Markov chain?
They all ended up in like a state.
Yeah! They ended up in a state that they couldn't get out of. Right? Now things were different and there was no way out of it. One of them, it depended on the initial conditions, and one it didn't. One of them, it did not matter originally how many people were going to Malia's versus how many people were going to Lisa's dry cleaner. And one of them, it very much mattered how many were going to which at the beginning. Do you remember which is which?
Equilibrium doesn't matter.
A regular Markov chain, it does not matter. We could have started off on that problem with the 3 social classes, with everybody in the third class, or everybody in the first class. It wouldn't have mattered. After a couple generations, we'd had whatever it worked out to, 40% in the lower class, 40% in the middle class, and 20% in the top class, or something like that. And it would not have mattered. On the other hand, on those absorbing Markov chains, it very much depends on how you entered the chain. If you started off with the absorbing Markov chain we spent so much time on was the game with the coin and Haley and MJ were playing. It very much mattered how much money Haley started off with, right? If she started off with $5 to $6, the likelihood that she was going to win was pretty high. The absorbing state that they got to was she's got all the money. On the other hand, if she started off with only one of the dollars, the absorbing state they almost always ended up in was she's out. Okay? That would be a subtle point. Okay? So let's put that on the, I don't know whether to put that on the review sheet or on the cheat sheet, but I don't see it as a huge deal. What do they call that? Do they call that the long-term forecast? Long-term prognosis for the system does not depend on the initial state for a regular Markov chain, but does depend on the initial state for a an absorbing Markov chain. Sure, I think that's worth telling. Let me take a look here and see if there's anything else. How would you tell which one it is? How can you tell a regular Markov chain from an absorbing one?
Absorbing has a 1.
Yeah, they've got there was 2 steps to it. You have an absorbing Markov chain when there's a state that you can get to that's got a 1. Once you're in there, you can't get, well, it has to be on the diagonal.
And it must be possible to go.
And it
from
has to be able
any-
to get to it.
Yeah.
Yes. Okay, so there has to be a 1, it has to be on the diagonal, and you have to be able to get to that state. Okay. Yeah, we didn't do any examples like that. There were ones in the book. They kept it a little bit simpler than that, where, I mean, in a regular Markov chain, you could have had absorbing states. You just can't get to them. But that's kind of trivial, right? I mean, if we had a regular Markov chain where there were four classes, lower class, middle class, upper class, and king for life. And when you're king for life, you're at, it's an absorbing state. You're out. But what if there was no path to get to king for life? And the way you get to be king for life is you slay 10 dragons, and dragons don't exist. Right? Well, then you've got an absorbing transition matrix. It's got a state you can't get out of. You're king for life, you're king for life. On the other hand, there was no path. What was the probability you get there from the lower class? 0, because there aren't 10 dragons. What was the probability you get there from the middle class? 0, because there aren't 10 dragons. What is the probability you get there from the upper class? 0. There aren't 10 dragons to kill to get there, right? Your book had a handful of problems that I didn't give you with this sort of trivial case, where, I mean, it makes sense you would just throw those out. The point I'm trying to make here is, just because there's a row in the matrix that has a 1, you need to double, that's what that business of making sure you can actually get to that case means. Does that make, you can get to that state? You need to be, there is a question on the test and recall us thinking that through. My guess is, well, that's another story. Anyway. And I don't know how to do any more about that without giving the answer away.
Do we need to do the thingy where, with the absorbing Markov chains, where we like rearrange it into the FR thing?
No.
Okay.
I would have loved to ask about that, but I think the test is long enough. Okay? I'm a little bit worried that the test might take too long. So no, that is not on there. Okay.
Combinations and permutations.
Well, let's work our way through the list as we've got it and put it together. Conditional probability and Bayes theorem.
I didn't mean Bayes theorem, but
You didn't mean Bayes.
I
Conditional probability?
Yeah, I figured out what Bayes theorem is.
That's not the one you meant? That's
Yeah,
good,
I
because
just
I don't
want,
think
like,
Bayes theorem is on the
yeah,
test.
I just want the formula for like,
Okay, actually.
yeah.
Okay.
Just
All right, let's do that. I'm going to look up, do you happen to know what page of the book now? No, I have a book of it. Okay. Let me just pull it up in the index.
7.1 is when we start talking about sets.
Yeah, we'll get to...
Conditional probability 7.5.
Okay, page 322. Conditional probability. Okay. I don't have any problem with this. Let's put that up here closer to where it would actually be. Here, let's make this a little more clear. Like, let's underline this and underline this. That we're talking about different sections here. conditional probability. All right. Conditional probability of event E given the conditional probability of event E given event F, written P E given F, is, okay, now, how do I want to write this? The probability of E given F, I'm sorry, that's not F, P given F, is equal to the probability of E and F, I won't look for that intersection symbol right now, divided by the probability of F. Hold on. For equally likely outcomes, let's see here. The probability of E given F also works out to the number of the cardinality of E and F divided by the cardinality of F. What they mean here is things like, you know, like if each possibility is equally likely. Like for example, if you're reaching into a bag and it's got blue blocks and red blocks and green blocks, well, each block is equally likely to get picked. Okay, that's what they're talking about. So like if you want to know the probability of picking a green square block, given that the block was square, and there's red blocks and green blocks, and some of them are round and some of them are square, then this works out, right? The cardinality, the number of blocks that are green and square divided by the number of blocks, or whatever. Okay, you know, oh, sorry, that would be, well, let's actually do that there, just so we're clear. You got a bag, and it's full of blocks. Some of the blocks are brown, and some of the blocks are green, and some are red. Let's do that. Some are round, and some are square. All right, let's actually put it there. You got round ones, you got square ones. You've got red ones, and you've got green ones. Let's say there are 4 round red ones and 3 green round ones. There are 5 red square ones and 8 square green ones. What is the probability of getting a green block given it was square? Okay, that's the number of ones that are green and square, 8, divided by the number of ones that are the second thing, which is square. How many are square? 13. Okay, so you've got both of those formulas. To be honest, I don't remember exactly how those problems. I have to admit that unit of the material is very similar to this class in quantitative reasoning, and so I have to admit I'm not sure entirely right off the top of my head how that all is. Okay. I agree, Bayes' theorem, okay. Bayes' theorem per se is not on the test. However, kind of an application sort of is. Remember I told you, well, we had 2 different tree diagrams on the test? Okay, Bayes' theorem was a way of thinking about those tree diagrams, right? Where like, if you were talking about, you made a tree and like, you had like, okay, there are students who can go to, they can either go to public school or they can go to private school. And once they're in public school, they can either go into, you know, something else can happen here. I don't know. They play sports or they don't play sports. Okay? I can't even write today. Okay, you got kind of a tree here. Okay, so like maybe 0.7 of the kids are in public school and 0.3 are in private school, and then like, well over here, okay, of these maybe 50% are playing sports and 50% are not, but in private school maybe only 20% of the kids are playing sports and 80% are not. Okay, and from that you could do things like, a given kid, what is the probability he goes to public school and plays sports? It's this times this equals 0.35. Okay, those kinds of working with a tree diagram kind of thing, that's all that is. Okay? Well, I mean, that's not all it is, but I mean, I don't mean that in a diminutive kind of way. It's just that it's not hard. And some of those things are kind of a Bayes theorem kind of thing, where like you're actually picking off your, you know, like for example, you pick off from here how many of the kids are playing sports. It would be this one and this one added up, you know, that kind of thing, okay? That's what was going on. It's not explicitly, the word Bayes doesn't appear on here at all. But I mean, it's that same set of problems that involve trees and stuff like that. All right. We also had product rule for probability. Isn't product rule for probability the one where if two events are independent, how do you figure out and? For independent events A and B, the probability of A and B equals the probability of A times probability of B. Now while we're up there, I've got no problem telling you that, what about the union rule for probability? Probability of A or B equals probability of A plus the probability of B minus the probability of A and B. And these are kind of related rules, right? When you're thinking union, you're thinking and. I'm sorry. You're thinking or. Oh, well, I think that gets us closer to something somebody was cranky about. Well, not cranky. Wanted to know about sets and set notation. Okay, we can do that. How about set notations? And to help with that, we're going to need those codes. Unicode intersection.
Oh, on Google Sheets, you can
Yeah,
insert it.
what did you say?
On
You can
Google
insert them?
Sheets,
Yeah, but
there
you have to have
go.
done it already once, haven't you? You have to?
What? No, because I just
Oh.
put them in, like, you have to go to the insert, and then you have to do the thing.
Okay.
If you just want to do it in your code, that's cool too. But-
Just out of curiosity then. Let's do that. So using under insert,
And then you go to special characters,
special characters.
and then you just type in.
Oh, really? There they are. Look at that. I don't think they have, most of the time that I'm doing this, it's in Google Forms, and I don't think that menu option of insert is on Google Forms. So unfortunately, I usually do it the hard way. Okay, so union was the other one. Union is this one. Let's use that one. That's what okay. So this equals intersection, and this equals union. Okay. Here's the deal. I'm a little bit leery to actually put on here which one of those is and which one is or. The intersection is and, union is or. That seems like a little bit too much information to put on the review sheet, right? You know what I'm saying? Like that feels like that's too far. What did we use in this class for complement? Was it the tick mark? Okay. Let's put that up here. Tick mark equals complement. The reason why I asked that is because the quantitative reasoning book uses a different symbol. All right. Good. What was else on? So you guys feel like you could do those? Hey, by the way, just because somebody made a deal of it, curly braces are used for sets. All right. I don't remember anybody making a big deal about the finite math final, but on the freak-out final, they freaked out about that. I told you about how I was talking to somebody from Ivy Tech.
Even though that we really didn't even cover sets.
Well, they used them as a way of listing the solutions. Like when we tended to do things like x equals 3 or 5, because there was two solutions to that equation, they wanted to make curly braces. Okay, it's in my notes for next semester. Let's use that notation because it makes the Ivy Tech people happy. It seems to me like that's kind of great. There it goes.
Yeah.
The last F I give. Anyway,
It's funny.
it's a thing. Everybody has to have the hill they die on. Apparently the hill they're dying on is curly braces are for
The
sets.
thing is that my hands, which represent all the gifts I give, are empty also.
Oh, no!
So,
All right, product rule and union rule. Expected value. All right, I think expected value is a fair thing to have a formula for. Expected value. For a random variable x that can happen n different ways. Like, for example, there can be 0 inches of snow, 1 inch of snow, 2 inches of snow, or 3 inches of snow. There were 4 different outcomes. Okay? The variable is how much snow we got. Okay? We're excluding possibilities like 3.5 inches of snow or whatever. Okay? We're just being simple. Or the ages of the students at early college. There's probably some 14-year-olds. Well, there's probably some 13-year-olds. There's some 14-year-olds, some 15-year-olds, some 16-year-olds, some 17-year-olds, some 18-year-olds, and there's probably even a couple 19-year-olds. Right? There's 7 different possible outcomes. And they have these there's a value. I pick a student at random, what's their age? They're 13, they're 14, they're 15, up to 19. The expected value of x is the sum of x I p I. I can't remember. Where pi is the probability xi happens. Does that make sense? So if there's a 1/10 probability that the student is 13, a 15% probability they're 14, a 20% probability they're 15, etc., okay, then it is 1/10 times 13 plus 15% of 14 plus 20%, right? Let's do one real quick. Let's do that one real quick. Okay.
And then can we do the binomial problem?
Yep, I'm going to try to help in different ways here real quick, okay? Alright, so real quick, so like if the ages were 13, 14, 15, 16, 17, 18, and 19, and 5% of our students are 13, and 10% are this age, 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 and 1, 2, 3, 4, 5, that doesn't really work out, 55, we'll just say, and 45% of our students are 19. Okay, you're all late bloomers. Alright, then the way we would find the expected value of the age of a student is you would take 13 times 0.5. 14 times 0.1, 15 times 0.1, and then add those up. Hey, it's another damn sum product. Right? It's the sum of the products. Hell, I'll even write that down. It's another damn sum product. Yes?
Is our final tomorrow or
Yeah, tomorrow first thing.
Ooh.
same time?
Yes.
So excited.
Yes. Got a question?
No. I was-
Okay. All right. Permutations and combinations. Permutations and combinations. CNR equals PNR equals. They both have n factorial in the top. They both have n factorial in the top. They both have stuff in the bottom. They both have r factorial in the bottom. One of them has something else. Before we get there, what is that something else?
N minus R.
N minus r factorial, right? Which one?
Combination.
Combinations, because combinations is going to be smaller, right?
Yeah.
Alright, I don't want to write down which one is which right now, but I want you to remember which one is which, Right? Think about pizzas, right? No one ever went and ordered, hey, we have a special today on our three topping permutation pizza. Right? They're combinations. Because the order doesn't matter. Yes?
Is it okay if you put like n equals like the like?
You want that on there?
Yeah, I get like n and r.
Okay. N is number of options.
Okay.
R is taken at a time.
Also, on permutations, isn't it on the bottom n minus r?
Uh-oh, is it? Did I make a mistake?
It's like on my notes and stuff.
They're both n minus r, but only one has the r.
Oh, is that what it is? Oh, crap. I'm sorry. I made a mistake. Like that?
Yes.
Okay. All right. I will double check that just to make sure before the test.
That's what we technically call math a boo-boo.
A boo-boo. Yeah. All right. What was else on here? Binomial probability and distribution. Okay. I'm going to tell you more than I should tell you. The only thing you need to know, you are not going to be computing any binomial probabilities or anything like that. What is the shape? Okay, what is a binomial? Okay, there is a question on the test that is, I'm describing something I've done here. Is that or is that not a binomial experiment? Remember there was that list of things that is explained, there was like 3 things that had to be to be a binomial experiment.
Yes.
Like, it had to have multiple trials,
Fixed number.
a fixed number of times, with a fixed probability each time of success, and success and failure were the only option. Like, well, there were 2 options, right? Like head and tails, or success and fail, or whatever, okay?
And repeated trials are independent.
And they're independent, very good. Didn't matter what the coin flip was, right? Alright, so like if I was rolling a dice, and I'm going to say, not rolling dice is hard. How about flipping a coin? We're going to flip a coin. We're going to flip a coin 100 times and keep track of how many heads we got. Okay? You'd expect it's going to come out 50 times, right? But it's not really going to be exactly 50, right? Then you flip them another 100 times. It's not probably going to be exactly 50. It's going to be 52 or something like that. But you could build a histogram of how many times what the sum was, right? You'd have to flip that damn coin a hell of a lot. But you could do it, okay? And you'd get that distribution of like, sometimes you got to skew maybe 25 times of getting ahead. Although that didn't happen very much. Most of the time you got around 50. Remember we got that bell curve distribution where things were binomially distributed? That's the kind of stuff you got to know. What is a binomial distribution? What does it look like? Like what is a binomial experiment? That kind of thing. That's all you got to know about binomial. Here's what I'm going to tell you. In the final version of the test, and the test is copied and ready to go, and I can't change it now, there's nothing in there about the normal approximation and z-scores. Just because I thought the test got long. Those questions got erased. We have already talked about how to do a standard deviation, and we've already talked about systems of equations. All right. I think that is what you need to know for the final. So, here's, yeah, go ahead.
Oh, also, like, I didn't bring it, but can we go over that one, like, problem about the socks on the study guide before we...
Oh, yeah, I meant to ask you about that. So on the study guide, there was a question about socks. Yes, because there was a question similar to this on there. I don't remember what the exact question was. Was it socks?
Yeah, it's like at the close to the second bullet point. Yeah.
There it is. All right. We have a laundry basket with 10 white socks and 10 black socks. You pull out 4 white socks without pull out 4 socks without looking. What is the probability you got 4 socks that are white? Yeah, there's a problem not hugely different from this on the test. It is different, but if you can solve this, you'll be able to solve that too. All right. Now, there are a whole bunch of socks in there. And when you grab 4 of them, they might all be white. And in fact, there's more than one way it could happen that you got 4 that were white. Like, you could get this sock, this sock, this sock, and this sock, or you could like not have gotten those first 2, but you got 2 other white ones. In fact, there are combination, 10 socks taken 4 at a time, ways to get white socks. Ways to get all white socks. Right? I mean, if you could tell the socks apart, there would be that many different combinations of 4 white socks there's 10 white socks taken 4 at a time. You can't tell them apart, but those are all ways it can happen. Meanwhile, there are 20 things taken 4 at a time, ways to draw 4 white socks.
Okay.
Right? I'm sorry, not white, 4 socks, period. Right? That's how many different ways, and that's a big number, because it's 20 factorial divided by 16 factorial. Well, it's going to be 20 times 19, yeah. And then you just divide these two, right? So this is the number of ways it could go right, divided by the number of ways it could go. That's all there is. All right? The problem isn't socks. It's something else, but that's the strategy there. Okay, so what will happen is sometime I will print copies of this review sheet. Like I said, I want you to use the review sheet, well, not the review sheet, the cheat sheet, but I don't want you to make changes to it. If you have something as you're studying you want added to it, send me an email, send me a text, whatever, and I'm perfectly willing to entertain the notion that it would make sense. These aren't That's weird. It's entirely possible it makes sense that I add that to the review, the cheat sheet before I print it. I probably won't print it until tomorrow, just so I'm certain that you have the latest and greatest information. All right, I know Andrew.
So, since our finals tomorrow, do we have class on Friday?
Here's the deal. The official word is we don't care if the juniors and seniors are in this room versus studying out in the study area versus preparing for other finals at home. As long as you are doing something productive, we don't care. We're not going to like the counting.
I have a question. So
Yes.
next week, if we have all of our finals done by Friday, do we have to even come?
I don't think so. I think the idea is just get it all done, but you should probably check. I think so though. I'm not entirely sure what's the story about Wednesday.
What if we do have a final next week, but because of testing on the days that we don't have class, do we go to class on the days that we usually have it?
Yeah.
No.
It's confusing because like.
Yeah, I don't know why.
Because I asked
Days
him
that
about
we
it,
usually
and
have
he
the
was
class.
like, I have no idea what's
Yes.
going on.